Hi, it's Dr. Arun Y. Patil from Department of Mechanical and Industrial Engineering from Manipal Institute of Technology, Bangalore. I am introducing a new course for Swayam platform under the head of climate change. So the course title goes in this fashion. It's Bioinspired Design and Climate Solutions, which focuses on from the concept to a POC or a proof of concept, including artificial intelligence, computer aided design, and simulation. The course objectives goes in this fashion. This will make the students to identify biological strategies and adopt them for engineering innovations. It enables students to apply AI techniques to optimize bio-inspired solutions. It gives a CAD and software skill set for design development and ANSYS for performance simulation. Design climate resilience prototypes addressing mitigation or adaptation goals. Develop a working POC with ecological or commercial viability. The entire structure is made such that it follows a course content which matches to industrial requirement, as well as it makes them independent when they enter into any of the industry. So the course content goes in this fashion, starting off with the introduction to bio-inspired design, climate change context and strategy mapping, idea to POC process which is involved through a biomimetic design, and then optimizing the the whole process by using a AI technique, product design and CAD tool skill set, and simulation and testing via a virtual module called as ANSYS, the project development, and then culminating into a proof of concept via a creation and industry interface. Finally, the entire thing will be pitched to as a business model. So the entire content can be uh, broken down into 7 modules, wherein the first module focuses on introduction to bio-inspired design, wherein the content will be what is biomimicry, history and global relevance, examples from nature such as nature efficiency, materials, mobility, water harvesting, climate focused case studies. For example, the termite mounds, whale fins, lotus effect, sheep horn utilization. All these are unique examples which, as a course coordinator, I have researched. So, this content will be for 6 hours. When we move to the module 2, the focus will be towards the climate change context and strategy mapping. This culminates in terms of the basic knowledge about the climate science, greenhouse effect, IPCC frameworks, mitigation versus adaptation versus resilience, technology, as well as nature based and market based intervention strategies, which will cover up for 6 hours. Module 3 focuses on idea to POC building via a biomimetic approach. So, wherein we try to observe by understanding the abstraction to emulation. So, biomimicry design via a spiral method. A case study walkthrough over a few of the research work based from my background. We have a bio NPK, which focuses on how to generate a bio based fertilizer artificially, termite HVAC, mangrove flood control, So these are some of the case studies which will be covering around 6 hours for the module 3. Module 4 focuses on optimization using AI techniques, which will be starting off with the introduction to AI ML in design optimization, then genetic algorithms, neural networks for parameter tuning, tool based workshop, optimization using MATLAB, Python, AI plugins. So this covers around 8 hours of engagement. Module 5 focuses on product design with a CAD tool, wherein we are preferring either a SolidWorks or a Fusion 360 as a solid modeling tool to understand the basic etiquettes about the CAD modeling. We will be covering the parametric design of a bioinspired design structures, as well as the group activity will be focusing towards the design of a nature based product. So the example might be a water collector or a wind turbine. So this covers for 8 hours engagement. Module 6 focuses on simulation and testing in ANSYS, which is comprising of structural, thermal, fluid simulations. Comparatively, simulation between the bio-inspired and the traditional designs will be validated, and then it will be verified for a climatic impact conditions. This will be covered in 6 hours engagement. Then we have a seventh module for project development and POC creation, wherein a team based proof of concept development will be addressing the climate challenges as well as tech and nature based integration. For example, urban cooling facade or microclimate control dome will be few examples. And then ideation to demo using integrated tools such as CAD, AI, and ANSYS. So this will be covered for nearly 6 hours of engagement. Finally, the entire thing will culminate into a industry interface and a pitching, which covers around 4 hours engagement, wherein we will have a guest talks from the sustainability background startups, policy experts, and group pitch-in sessions for through expert panels from industry as well as the startup young budding startup entrepreneurs, and also the evaluation and feasibility aspects, and then finally trying to see the pitch in how they can able to make that. So this entire thing will be for 50 hours engagement. The prerequisite for this are the student should be complete, or the student should have completed BTech second year with a CGPA score of more than 7.5, and the learning outcomes out of this we can expect. Students will be able to identify the biological strategies and adopt them for engineering innovations, apply AI techniques to optimize bio-inspired solutions, use CAD software for design development and ANSYS for performing simulation, design climate resilient prototypes addressing mitigation and adaptation goals, develop a working POC with ecological and commercially viable aspects. And the examination pattern will be, the entire thing will be either problem based or a project based learning and assessment. Usually a real time or a real world industry based problems will be given to carry out their product development process with individual or maybe in a team of 2 members. The assessment method will be in 4 phases. Initially, it starts off with a midterm exam of 20% weightage, wherein a bio inspired concept or a climatic framework will be the criteria to decide. Next 20% weightage will be at the laboratory level of evaluation, wherein the CAD tool and the ANSYS performance will be measured. The third phase will be the group project and the POC demo, wherein a 40% of the weightage will be given. We will be assessing through the functionality, originality, sustainability of the whole product. Finally, the viva and the presentation, which will fetch them 20% of the marks, and minimum passing criteria is 50%. The grading scheme will go like above 91% will be A plus, 81 to 90% will be A, 71 to 80% will be B, 61 to 70% will be C, 51 to 60% will be D. So minimum passing criteria will be they have to score above 50%. Number of credits will be 4 credit course, and we have NCRF level as 6 here, and industry linkage we can able to connect with companies such as Philips, GE Appliances, Tata Elxsi, Godrej Innovation, and Siemens, Mahindra, Ather, Ashok Leyland, and even Tata Powers. So these are some of the companies which panel members or the experts will be coming out, and they will be also validating the outcome out of the process through which the students would have undergone. Thank you.